Hey everyone, I want to take a moment and introduce a couple of different subjects. We'll get into more detail on both of them. But I really want to give a structural background or a physical background of a couple of different things. So center of mass and centroids, those are roughly the same thing. Centroids are generally like the center of mass for an area. So we don't consider the mass, we just consider the area over which it's laid out. Center of mass then takes it another step further and looks at maybe the way the mass is distributed, or maybe they're made of different materials. So we maybe go a little farther. We'll start with centroids, but then we'll venture right into center of mass. And then I'll get to these three in a second. But let's talk about center of mass or the centroid. And I'll take a nice ruler here. And the center of mass of a ruler is generally going to be right there near the middle of the ruler. And I know that because if I balance it on my finger, it stays in that location. If the center of mass of a physical object is above or below the support mechanism, then it will not rotate. All right, there's no net torque or net moment acting on the object. And it turns out it's a much more stable system if that center of mass is below the support mechanism. We'll get to that maybe later on. Okay, so if I take my finger and I put it over here, clearly it's not going to support because there's more mass over here, consequently more moment rotating this way than is over here on the right, rotating it this way. Okay, so the center of mass of a nice uniform shape is right there at the middle of the shape. But that's not true if the shape is not uniform or structured differently. So you may recall my fixed support from a couple of videos ago. If I go to the middle of this bar, which is roughly the middle of the system, and I put my finger there, it's not going to balance. If I want to balance this, I got to find someplace else where it's going to balance. Not too far from there. So there I'm balanced. So the center of mass of this system, the bar and the base of the stand, is going to be located right at where my finger is. Okay, that's the center of mass of that system. All right, and there's a variety of different ways to find the center of mass. In one dimension, left and right, supporting it at that point will tell us where it is. If it's in 2 or 3 dimensions, generally what we like to do is hang it from some locations, and we'll find out where the center of mass of that would be. And I'll get to that in a later video. All right, I can also take something like this bar here, and I've got a couple of clamps on it, and the center of mass is roughly at the center of the bar. Maybe not quite, right? But if I change the position of one of the clamps, it's not going to be at the middle of the bar any longer. It's going to be at some other location off the center of the bar. Okay, so now it's balanced, and so the center of mass is at my finger, which is different than the middle of the bar. Not much different, but a little bit different. Okay, so that's a little bit of a discussion on center of mass. But then let's take a look at these bottom 3. And I want to do that because I've kind of got the equipment here to show this. I've got rotational inertia, moment of inertia. Those are basically the same thing. I've heard both terms. Moment of inertia is what we use in most of the physics and engineering texts that we've talked about. Mass moment of inertia is also going to be important. Moment of inertia in engineering can again have to do with an area or a volume, but nothing to do with mass, whereas mass moment of inertia is distinctly with the mass and how it's distributed and what things are made of. But what's the term mean, right? What does all this mean? Inertia is the critical issue here, and I can show that best with this bar. So the idea behind inertia, if we go back to Newton's laws, and the idea inertia was something that Galileo came up with some hundreds of years ago. And his idea was the measure of inertia is the tendency of an object to want to change its motion. And so it really goes to Newton's first law. A body in motion will remain in motion, moving with a constant velocity. That is to say, moving in a straight line with a constant speed, unless acted on by an outside force. And so it takes an outside force to change that motion. It takes an outside force to change that motion. And so rotational inertia, or moment of inertia, mass moment of inertia, have to do with motion in the rotational direction. Now, for linear inertia, and Newton's law Newton's first law, it's all based on mass. But for rotational inertia, it's based not only on the mass, but also the way the mass is positioned. So let me bring this object under rotation and I try to stop it. Okay, so I'm rotating it and stopping it and making it rotate the other way. So I am altering the rotational motion of this object. If I do that with these clamps to the outside, and I love to do this as a demonstration in class, when I do this with the clamps to the outside, it's very difficult to stop it and make it reverse direction. But if I take these clamps and I move them towards the middle, and I'll keep them centered just for the sake of simplicity, or evenly distributed, and now I begin to rotate it, it's a much easier thing to do. Rotating this and changing that rotation is much easier than it was when the clamps are to the outside. And so it's not just a matter of what's the mass, because I didn't change the mass. The amount of bar and clamps is the same as it was. Nothing changed there. But it's more difficult to rotate than it was when the masses were to the outside. So the moment of inertia, the rotational inertia or the mass moment inertia, they're going to depend on where the mass is distributed or where the area is distributed in rotational inertia. And that's what we'll get into in more detail. The beauty of these two things, and the reason I bring them together, is they're both based on integrals. And the integrals are almost identical, but we'll look at that when we get to that section in a later video. All right, if you have any questions, please leave them in the comments below. Thank you.